Lesson 3.1. In this lesson, we will take a look at the relationship between multiplication and division, which we typically think of as opposites, and we will apply that understanding to fractions. Let's take a look at problem 1. Eggs come in cartons of 12. A dozen eggs, of course, means 12 eggs. While grocery shopping, the Kwan family buys 4 cartons, and you can see that visually represented here in the picture. 1, 2, 3, 4 cartons. 12 taken 4 times equals how many eggs altogether? Well, 12 taken 4 times is 48 eggs. 12 times 4 is 48. Or the reverse is also true. 4 times 12 is 48 eggs. Number 2, Mr. Kwan's family uses a quarter or 1/4 of a carton of 12 eggs. So 12 taken 1/4 times is how many eggs? In other words, what's 1/4 of 12? In this case, it's 3. 1/4 times 12 is 3. Look at these first 2 examples. Over here, we were talking about 12 eggs, 4 groups of that. Over here, we're talking about 12 eggs, or a set of 12 eggs, but 1/4 of a full set. If a full set is 12, what's 1/4 of that set? In this case, that was 3. Complete each equation chain like the one shown. So number 3 has been done for us. If we were to make a visual model of 10, I could do it like this. What's 1/5 of 10? Well, imagine that I was to divide this into 5 equal parts. 1/5 of 10 could be shown like that. 1/5 of 10, you could replace the word of with a multiplication symbol. This dot is another way of showing a times symbol. In other words, if I was to just write something over here like 5 times 2 equals 10, another way of showing that, another way of showing the multiplication symbol is to use a dot. 5 times 2 equals 10. But notice the position of the dot is in the center. It's not on the bottom like we were used to seeing at the end of a sentence if we're using a period. This dot is at the center. Back to problem 3. 1/5 of 10, another way of writing that is 1/5 times 10. Or you could say 10 divided by 5. In other words, I have 10 items and I'm dividing them into 5 equal parts. 10 divided by 5 could be shown as a fraction, 10 over 5. I'm taking 10 and I'm dividing it or splitting it 5 ways. If I have 10 items and I'm dividing them or splitting them 5 ways, then each part has 2. Let's look at number 4. If I'm representing 1/6 of 18, again, imagine that I make a model here of 18. And here I'm going to do it like this. 1/6 of 18. Could be shown as a multiplication expression, 1/6 times 18. It could be shown as a division expression, 18 divided or split 6 ways. It could be shown as a fraction, 18 over 6. And then finally, it could be shown for its actual value. 1/6 of 18 is 3. Number 5, 1/8 of 32. It could be shown as a multiplication expression, 1/8 multiplied by 32, or 1/8 times 32. It could be shown as a division expression, 32 divided by 8. It could be shown as a fraction, 32/8, or 32 over 8. And finally, it could be shown for what it is, whole number 4. Number 6, 1/5 of 15. Could be shown as a multiplication expression, 1/5 multiplied or times 15. Could be shown as a division expression, 15 split 5 ways or divided by 5. Could be shown as a fraction, 15 over 5. It could be shown for what it is, whole number 3. Question 7, 1/3 of 27. Multiplication expression, division expression, fraction, 27 thirds or 27 over 3. And finally, for what it is, whole number 9.